Welcome to a short video from AKF Partners on best practices in sizing your microservices. At AKF Partners, we work with many clients on application architectures from new greenfield applications to well-established, long-tenured monolithic applications that are undergoing transformation to distributed microservices-based architectures. Companies struggle with common challenges as they implement microservices at any size or age of an application that we will discuss here. Why break an application apart into services in the first place? Or if starting from scratch, why not build the application as a monolith? Great questions. These are big topics, but suffices to say that distributed architectures help teams innovate more quickly as an application grows. A monolithic application may be just fine in the early stages of development and finding a product market fit. Most new concepts begin this way. Once the application starts to grow more quickly, the engineering team also grows. Branching the application into small pieces will allow each individual team to move more quickly with fewer dependencies. When microservices are done correctly, the team's velocity will be maintained or even improved. Where to start when sizing and scoping new services? Let's start with the individual Scrum team. In an agile development model, maximum team size should be about 8 to 12 people. Ideally, microservices should be sized such that each Scrum team owns only one microservice and no service is split between agile teams for development. The most common misstep we see is team sizing microservices to be too small and therefore agile teams owning multiple services. While this is workable, it adds more complexity since there are more separately developed and deployed pieces of the product. This complexity adds cognitive load in development as well as operational complexity, therefore also risking lower availability. It's acceptable for a single Scrum team to own 1 to 2 services, but ideally no more than 2. We see the creation of too many services as a common issue with greenfield applications more so than when decomposing a monolithic application into distributed microservices. It's easier to build small services when you're starting from scratch than when dissecting or decomposing an existing application that is fraught with dependencies. Should I still size my services in this way if my product is growing quickly? Considering how and when to break your product into microservices is always a good idea. It's important to consider how you would perform future splits with growth over time. Evaluate your application, the modularity of the code and its data structures, and based on logical subsequent microservices to be decomposed, make it as easy as possible to perform future further splits. The headline is to architect within a service in anticipation of application growth, whether that growth is imminent or not. Now that we have established guidance on the size of a service, how do you determine the scope or functionality contained in each service? Most teams use event storming and/or domain-driven design as tools to help guide the process of defining services, their scope, and their alignment to agile teams. These are meaty topics in and of themselves and are well documented by their authors and the engineering community. Domain-driven design is a concept introduced by Eric Evans in his 2004 book, Tackling Complexity in the Heart of Software. DDD is an approach for architecting software design by looking at the software's key functionality from the top down. Event storming is a rapid group modeling approach to domain-driven design. Event storming was originally created by Alberto Brandolini in 2012 as a quick alternative to precise unified modeling language or UML diagramming. Event storming is a workshop-style technique that brings together tech and non-tech product stakeholders to explore complex business domains. While event storming utilizes DDD, it's not exactly the same. In DDD, small groups or individual engineers have conversations with product owners and then begin modeling, often on their own. Whereas event storming looks at modeling in a group setting strictly through domain events. A domain event is something that happened in the application that you want other parts of the same domain or product to be aware of. The notified parts of the product usually take action based on the event. Identifying domain events forces everyone to use the same language when discussing the domain and to focus on events that are part of the user journey as opposed to hypothetical scenarios. In summary, these techniques help break the application down into logical groupings of feature functionality that can be scoped in more detail and will be the foundation for individual services owned by agile teams. Let's take the example of an e-commerce application. This type of application will have common capabilities such as search and browse, view item, add to cart, checkout, and so on. Each of these capabilities could be a separate service owned by a separate Agile team. Or conversely, a checkout service could include all of pay and ship capabilities, but be architected to make it as easy as possible to split shipment and payment into separate services in the future. Other best practices when scoping services is to plan for individual Scrum teams to have a whole vertical slice, including the user experience or front end. The team's responsibilities flow through to the application logic and the data structures in the data store. This means that Agile teams should be structured with full stack development skills. The reason for this design principle is to drive team-level autonomy by making sure the team can manage all aspects of the design and delivery of their service from front to back end. Of course, there's still a need to make sure the end-to-end user experience is optimal and services work seamlessly with one another. But in short, we want to make sure individual Agile teams can have as much autonomy as practically possible in order to accelerate time to market and minimize cross-organizational dependencies in development and in production or operation of the product. In addition to optimal sizing and alignment to your application functionality, here's a short list of additional service scoping design principles to consider, including how often a piece of functionality changes. This is a proxy for the level of innovation needed in a given area. Costs to perform the split. For example, when working with an existing application, certain splits may be very expensive based on the complexity and number of dependencies that must be addressed to separate. Business criticality of the functionality to the application, as well as future reuse opportunities. Following is a simple decision tree to help guide and refine your service split analysis. Hopefully, the approach and principles described here will help you optimize your distributed architectural journey. We work with many engineering teams to design and evolve their applications over time. Call us, and we can help.